So welcome to my talk about voice interactions on Android. So on Android, of course, I'm going to talk about technical solutions on how to implement, on how to use voice with Android devices, but a bunch of things that I'm going to talk about today are actually applicable to iOS or to the web or to any platform. So who am I? I'm Elaine. I work at Sphere here in Paris. Don't hesitate to contact me if you want to chat about everything I talk about here, or mobile development in general, or development in general, LinkedIn, Blue Sky, or even my work email right here. Welcome. Come. So, the white outline for today's talk, why you should even care about voice, what you need to do, how, a little bit of history of voice on Android, third-party stuff, and then some final conclusions. So first of all, why? Why should we even care about implementing or thinking about interacting with voice with any system, not even Android, only Android? The most evident one maybe you can think about for everyday life is hands reactions for very specific contexts, such as you're driving in your car, you can do some quick commands to your system to get an answer about something or so on. If you're cooking, your hands are dirty, so it would be really cool to have an app, a recipe app, for example, where you could command, go to the next step, and so on, while your hands are dirty. And even some occasional contexts where, for example, disabled people who have accessibility issues, either permanent or contextual. For example, I gave this talk once. I had some accident, a ski accident, or I couldn't use my right arm, and for me it wasn't a temporary disability that I had. A bunch of folks are concerned about these issues. So either people who have dexterity problems, who cannot, maybe some folks who even don't have hands, folks that have some visual problems, hearing problems, and so on. Not hearing, but visual problems. And some folks even that we don't care about, we don't think about that much. Folks that maybe have some cognitive problems as well, that don't understand user interface or who cannot read. It would be really cool to, so everyone, either kind of accessibility issue that they have, they can actually interact with natural language, and the system can interact with them through voice. It is really a great solution to be giving our users. And last but not least, voice-rich experiences can be really cool for everyone, for even most of us here who don't have any kind of disabilities, having just the possibility to use your voice anywhere. And I think more and more people are being maybe comfortable using their voice, maybe not in the metro, not in the bus, I don't know, but I see more and more people, even in their, some people, but we'll see how adoption goes, even on their work life, using voice commands to say something to ChatGPT or so on. So I think those interactions are getting more and more accepted and more used. So just building voice-rich experiences can be really cool. So now, hopefully you are convinced that you should care a little bit about this, and what you need to do to actually integrate voice in your systems. So there are four blocks or four building units that you need to integrate in your system, in your app, if you want to build a fully voice-forward system or application. So the wake word detection is speech-to-text, NLP, and then text-to-speech. So the wake word detection, it is the wake word or the trigger word. It is for the system to basically start listening. Most of the time, or even 100% of the time, this happens on device, this happens offline. You know, you have your Hey Google's, Alexa, or Hey Siri here, sorry. And this is basically your system that is always listening, but it is happening on device, and this basically triggers the system to start listening to your command. Then you go to the speech-to-text. Speech-to-text is basically you set something with your natural voice or even a little small word, and then you have the speech-to-text block, and then you have your transcription. For example, here you have an audio signal, and then order a picture, for example. And then you have NLP. NLP stands for Natural Language Processing. Sometimes we can also talk about NLU, Natural Language Understanding, where we actually, you know, for the best systems in general, what we allow our users is to talk to your app or whatever in the way that they want, and then you capture what we call the intent. So, for example, for ordering a cheese pizza, maybe I'm going to say order a cheese pizza, but another user is going to say I want a cheese pizza, or I want to buy a cheese pizza, please. And then you're not going to parse. You could, for very small systems, simple systems, it can be enough, but you're not going to parse word by word. You're going to go through this algorithm that is going to extract something that we as developers can use to do something interesting with. So for example, here we're going to extract the intent that is going to be order, and then parameters there's going to be cheese pizza. Of course, all of this you have to work on your algorithm. There are a bunch of solutions that exist, but you have to work on this. Then I didn't say, but this is the time. Of course, you have those parameters. Then you're going to be using some kind of external service. You're going to be do API calls, go look at your database, go do a server call or whatever, do some business logic. And then your system is going to give back to the user something that is going to be said to the user. So you have a textual answer. For example, your command to order a cheese pizza went to the server, everything went fine, you paid for it, and then you have your answer, pizza successfully ordered, and then you have your final block here, the text-to-speech, that is going to say back to the user the final answer. So again, this is the whole system. So from the user that is making a wake word, so wake word detection, speech-to-text, NLP, business logic, that is going to do whatever your business is doing, and then text-to-speech back to the user. So this is the whole system. So it is 2025, and it will not be a 2025 talk if I didn't talk about LLMs or GenAI. Sometimes I think a lot of people they don't mistake, but they think about those systems only by using LLMs instead of NLP. NLP is there are many years behind those the building of those algorithms, but nowadays sometimes there are systems that are actually using LLMs. LLMs are very good, are very specific things. For example, chat apps, summarizing and doing some stuff. If your use case is this. If you want to get something from a user and do some kind of summarization, chat application, LLMs are more than okay, are very good for this. But these NLP solutions are the most common ones when we talk about this kind of applications. Then there are other more advanced blocks that you can actually do. They're not it's not that they are not used, but they are less common to be seen on those systems. So for example, there's voice activity detections. If you have a lot of noise in your system, there are solutions that are specializing on that. Language detection as well. If your app is only for French, only for French users, you don't need to care about it. You just put everything in French and it's fine. But maybe it is localized, so the very first step would be, oh, he's speaking French, English, Portuguese, or whatever. So you have solutions specifically for that. Speaker diarization. Most of the time, again, there's only one speaker, but you can have 1, 2, 3, 4. And diarization is being able to separate those streams. Okay, speaker 1 said this, speaker 2 this, speaker 3 this. So this is called diarization. And then I put here a prompts or prompt engineering. It would be the way that we talk up with systems are kind of being very since Gemini, ChatGPT, and so on are being so used. I think people are getting used to talk to those systems as if they were prompting. And something that is very advanced, and as far as I know, as developers, I think Gemini and ChatGPT and so on, they can handle it in their app. But we as developers, I'm not aware of any solution that is actually able to catch interruptions. So, for example, my system is giving me back the answer, and I say, "Oh no, not this, this," you know, and I just interrupt the system, and it's very hard today to detect this. So, this was the what, and then how. How do I do it? There are mainly 3 strategies in order to integrate voice with your in your app, or in the voice ecosystem as a whole. So let's take a look at those. So the first one is actually you can integrate with an existing platform, because there are voice forward or chat forward platforms that exist today. So even though it's kind of dead, the Google Assistant still exists. We're going to be talking a little bit about that afterward. And then there's Alexa and Alexa Plus. Alexa Plus just was launched in the beginning of the year, I think. And then, of course, some chat platforms that work really well, and you can integrate with them, even though they are not voice forward, but still they are chat forward, and I think it's like a subcategory of a voice forward solution. And the most interesting for us as developers that build apps is actually integrating in my actual solution. I have a banking app, I have a supermarket app, or whatever, and for that, if you want to build voice interaction in your app, you either are going to be using first-party APIs, either from Android or Google as a whole, but there are a bunch of third-party SDKs as well. We're going to be taking a look at a bunch of examples just after. And this slide here, as I was saying before, I gave this talk a lot already, and I used to say, okay, you can actually do, before I used to say, oh, if you have machine learning engineers in your team, or people that are really, really specialized in this, of course you can do some sort of in-house development. But nowadays, with the democratization of AI in general, I think there are a lot of things that are more feasible in-house. So don't hesitate to look at some stuff that is available for everyone, and I think it's much more democratized, it's more democratic, and much more things can be done like in-house custom stuff. So first-party solutions, so voice on Android. This is a summary of everything that was launched either on Android or by Google since the beginning of the Android versions. And you can see there are a bunch of things on this slide, but I don't want you to take a look at all the details here. What I want to bring to your attention is that the very first versions of Android, so 2009, 2010, they already had text-to-speech and speech recognizer APIs, available to developers. So those, the words here in green, the terms in green, those are the APIs that are available to every Android developer, basically, which is really, really interesting. And you can see lately what has happened on Android is actually, of course, text-to-speech and speech recognizer APIs are still there, and they're getting better and better. And on the latest years, what we have seen is more and more on-device support, so offline support and on-device support. Then here in black, I put the Google solutions that are basically the father, great-grandfather, and great-great-father of Gemini, basically. For those who remember, in 2012, we had the very first version of Gemini, or the assistant of Google, which was Google Now. Then they had the Google Assistant in 2016. And then finally, 2023, Gemini. And the latest model of Gemini, of course, Gemini 3 Pro launched this week, and Gemma 3, which is the open model of Google that allows us to use GenAI stuff in our systems. So if you want to focus only on either Android or Google provided solutions, you can actually do everything on our main system here by only using Android solutions. I'm going to talk about just after voice access. You can actually use for the work detection, the speech recognizer API and text-to-speech API directly from the Android APIs, basically. For the NLP part, there's a Google solution called Dialogflow. So you can do everything only relying on those solutions. Of course, if you're Android forward, maybe you only have Android users, or for some reason, yes, your application is only on Android, you can stick to this. But again, maybe, and of course, this one is the closer to the system. So as I said, there's a bunch of advantages getting like stuff on device and so on, working directly on Android. So this is the most, I would say, performant or optimum for Android systems. Voice access is something that I learned about maybe 1 year ago or something like this. I didn't know about this. This is actually an accessibility feature on Android devices where you just basically turn this on and you can give commands to your Android device, and it's very, very powerful. I was very impressed with this. So even for you, as I said in the beginning, okay, maybe you have a recipe app or something like this, and I want to control it with voice. If the app doesn't support any kind of voice interaction, by turning on this accessibility feature, maybe it is enough for you. So, I mean, here, of course, you see Chrome, Google Chrome and Open Chrome and YouTube. But maybe even for most apps, it could work, you know. What about Google Assistant? The Assistant is still today officially existent on Android. There is actually, I wasn't going to talk about this. At some point, I'm going to stop talking about this, but it is just something that I think worked and still works actually. I don't know until when. It is the communication between one Android app and the Google Assistant. There's actually, by just doing some configuration, by declaring capabilities that your Android app can do, you can actually, I said that you should do wake word detection, speech to text, NLP, text to speech. Instead of doing it yourself in your app, doing everything that you need to do with all the difficulties that you may encounter, with this solution that is called App Actions, you actually declare with a configuration file capabilities for your app. So this is inside your Android project. So for example, here I have an app, maybe there is a fitness app or something like this. So for start exercising, and then configuration, you know, you say, oh, what is the package name of your app, the activity, basically the screen that you should open, and parameters that are going to be taken by your system, and then that's it. Basically, your user, through the Google Assistant, they'll say, okay, I would start a running exercise, something like this, for 30 minutes. And then, since your app contains this, it will open your app with those parameters at the right screen and it will perform the action. I think this is so powerful, but it is underused. And we'll see what happens with Gemini. I would love to see some kind of integration like this, but we'll see. You see all of the native actions that you can do with App Actions. You can see there's a lot of health and fitness, transportation, productivity, communications, but you see you have the common features right here. Open app feature, basically opening a specific screen in your app is feasible through this. And very quickly, since conversational actions from the Google Assistant are actually deprecated since more than 2 years, conversational actions were the apps that we as developers could use in the Google Assistant ecosystem to, for example, I don't know, you are Sephora, for example, you have your conversational action in the Google Assistant. You could say, okay, Google, talk to Sephora, and then, oh, yeah, I want to browse some stuff, products, and so on. They have been deprecated. But app actions, the way to extend Android apps to the Google Assistant, they still exist, but they are different solutions. So, and again, a lot of people used to make some confusion about this. The Google Assistant is not Android. Some folks, they thought they were. It is present on Android, and is not like Siri. Siri is coupled with iOS. So I said, okay, it would be great to see this stuff on Gemini, but what is actually feasible with Gemini today? First of all, we are kind of this transition phase where we still have, as far as I have checked, you can actually have both apps installed on your Android device, which is interesting, but you get this like migration chat where your actually this is where I think when you launch the Google Assistant, you get this, the try Gemini, and then, okay, your assistant will become Gemini, and this is how you use it, basically. So, of course, the interest of Google is to migrate everyone from the Google Assistant to Gemini. So, as for the assistant that is present on Android devices, expect people to have Gemini nowadays. And then, of course, you have the live interactions, and then you have your whole Gemini experience right there. But the thing is that we don't have app actions. We don't have a way of communicating Android apps with Gemini. Gemini lives in its own world, but in our apps we can use the Gemini API. And Gemini API, I put here the Gemini 3, but Gemini 1, 2 also, they had audio capabilities. And then you can, Gemini can intake a bunch of different files, audio files, to either describe, summarize, provide transcription, and so on. And this is why I asked you the question just before, because, as I said, I did this slide before. And you can see here I have 6 bullet points, and here I have 5, because this was for my previous slide, and this is the actual documentation. So who can spot the difference? Difference is right here, documentation from April this year, documentation from September. It is that before, actually in the documentation it said that Gemini was only transcribing text that was written in French, and then since September it expanded to I want to say dozens of other languages, which is great, because before it was only in English. And what does this mean for our system? Basically, we can replace the speech-to-text and NLP part with Gemini API if it makes sense to your system to actually use the Gemini API and its capabilities, since this is actually an LLM. Then another solution from Google is actually using Gemma, which is the open model of Google, and for me, the biggest advantage of using Gemma is that you can either host it yourself or host it on the user's device. Of course, it takes gigabytes to do that, but the main advantage of doing so is that you have offline support, you have much less privacy issues, and yes, you can do inference on device. Of course, the model is not as powerful as Gemini, but still, again, for a use case, it made work. And why did I put MediaPipe right here? Because the way to talk with Gemma basically on a device, you're going to be using MediaPipe. Then There's another solution again from Google, which is Gemini Nano. Gemini Nano, it is embedded. Basically, right here you can see the Android OS, so the operating system that is on your device has this AI core brick right here where you have Gemini Nano that is actually already present on device. The biggest advantage is don't need to download, don't need to do anything on your device. It's just there and you can start working with it. The biggest disadvantage is that there are very, very few supported devices today. So basically the Pixel series 9 and up and the latest Galaxy devices, Galaxy S24 I think and S25. But again, if it makes sense to your business, to what you want to accomplish, you have this option as well. I was talking about MediaPipe before to use it with Gemma, the open model, but this is not about voice, but it's about audio. I think it was interesting to see that you can actually also detect audio coming from your system as well. So just so you know, and this also happens offline. And last but not least, to finish this Google part, if it makes sense for you, if you're already on the GCP, you have APIs from the GCP that exist, speech-to-text, text-to-speech. They work really well. You can use it of course, in your server, and then you call the API. They work really well. Again, if you're already using, they work just fine. To summarize, this is only the Google solutions provided by Google. So you can either use APIs directly, you can from Android, so for us developers, you have actually features that are already present on the system that you don't need to do anything as developer, but the voice access and voice actions. I talked about app actions, but again, I don't know until then they're going to be available, but they still work today. The Gemini solution family of solutions, so Gemini API, Gemini Nano, and Gemma, MediaPipe, and then just GCP, sorry, and Dialogflow, which I said that is doing the NLP part, is also hosted on GCP. This is DevFest. This is a Google event, but the world doesn't revolve around Google. There are many other providers out there. So I'm going to be giving some other examples, some other solutions that are tackling this problem. So again, this is our whole system. And then for each solution, it's going to either be providing a solution for the whole system, or maybe just speech to text, or maybe just text to speech, So just have this in mind. I'll put right here on the top which solution is being provided by the solution. So Pico Voice for me is the most impressive one because it is, as I put here, it is doing everything on a voice forward system, and you can start for free. I'm not endorsed by them, but I just love them, their systems so much. And my demos just after are going to be given by them. Everything is running offline, and of course, the biggest advantage of using those third-party solutions is that it's cross-platform. You can use an Android, iOS, on the web, even Raspberry Pi embedded, and so on. So you're going to be seeing some demos with them afterwards. Of course, Amazon and Microsoft, they both have a bunch of solutions right there. So as we have for GCP solutions for speech-to-text and text-to-speech, we have for Amazon and Microsoft as well, and either offline and online. OpenAI, the creators of ChatGPT, they have their own solution for speech-to-text. So this is for speech-to-text. I see it's very, very popular. And you can see right here the parameters that they have, the size and so on. And I put here some reference of folks that have made Android apps using those APIs. That work really well. Again, coming from ChatGPT, you can only, OpenAI, sorry, the creators of ChatGPT, you can only expect that they do a good job. And then finally, as I said in the beginning, in-house development, I think it's much more to I mean, even me as a front-end developer or Android developer, I think I'm able to go like to Hugging Face, which is, as they sell themselves, the GitHub of GenAI or AI, where you can actually see, for example, I put right here, I have on the natural NLP, so natural language processing, you have all of these categories right here. Behind each category, you can see I only put some examples because I put here 90,000, 21,000. There are so many things available here. You can actually download. You can actually, everything here is provided for free if you accept their terms of conditions. And you can use it in your app, in your system, and they have the like tutorials, examples, and so on. If you find the right one for you, it's great. And you see, you even have stuff that is specialized for very specific tasks, for example, question answering, translation, and so on. So definitely don't hesitate to try stuff by yourself. I think it's not that easy, but if you put enough energy on it, I think we can do really cool stuff. And in concerns of like, especially in Europe, with privacy and systems that are always listening to us, there are so many people that have been interested by systems that are working offline, either LLMs or building basically your own Echo device or your own smart speaker. There's so many examples that we can find on the internet where we can build our own system. So if this is something that is interesting you can find a bunch of things online, and it's really great to see. So let's take a look at the demos. I forgot to say that I have audio. So the first example is basic. As I said, all the examples are coming from Pico Voice, and this one is basically where the user is saying the wake word, which is computer, and is only that, only so you can start seeing how this works.
Computer.
So you see right here is detecting. I mean, it can seem really simple, but you can imagine how complicated it is actually behind the scenes, but it is working even, I didn't say even with the app closed on background. This one, a little bit more complex. It says the wake word with a Pico clock, starts listening. It says, it gives a command, set a timer, and then it gets the intent and so on, and it does a visual answer. It doesn't do text to speech.
Pico clock. Set timer for 25 seconds. Pico clock. Start stopwatch. Pico clock. Stop stopwatch. Pico clock. Show me the time. Pico clock. Show timer.
Again, may appear very simple, but you see, you have 3 sections in your app. It is actually synchronizing everything with you can actually see by yourself that there's no hands at all being said here. You have your wake word, your instruction, and the actual action that is being happening here. And you, of course, since Pico Voice, as I said, is a cross-platform solution, you have even here an iPhone and an Android device, and it's really impressive to see. And this one, oh.
Hey Batista, give me a small double shot mocha.
So give me a small double shot mocha.
Hey Batista, can I have a large coffee?
Again, I show you this example only so you can like maybe think about something that you could do in your app or something that you have in mind. So this is where I'm showing everything here. And this last example is actually using an LLM that is running on device.
Tell me about igneous rocks.
So tell me about igneous rocks. So it's asked about some definition.
These rocks are formed from the cooling and solidification of magma or lava. They can be classified
And
into
this is the CPU and memory usage, only to show you that everything is happening on device. To be 100% sure, it should use, it should show the actual network layer, but they don't have it here, but we will have on the next example that is going to be running on an iPhone. Again, here. What is the tallest mountain in the world?
Mount Everest.
Pico voice. Tell me a joke.
Here you can see the network part, zero kilobytes, everything running either loaded on the memory and running on the CPU. A joke, a very bad joke, doesn't matter. What matters here is that everything is happening on device and all of the chain basically. Give me the final thing. Okay. I didn't put it here, but it was actually the whole chain. The wake word, speech to text, LLM, and then text to speech, because it was talking back to the user, which is really, really impressive. Okay, let's wrap up. Most important diagram of this talk. Hope you grasped what you need to do in order to build fully voice-forward application, either Android or any kind of application. But what I didn't tell you, I kind of told you through the examples, but not all of the bricks here are actually mandatory. Maybe for your system it makes sense only to be using, I don't know, speech to text for some kind of reason, or not giving audio answer back to your user. It really depends on your use case. And of course, you can mix and match solutions. I said, okay, maybe you can do full Android solutions that work really well on device, or you can do like Pico Voice for everything. Lex is the NLP for Alexa, with AI, if I remember well, from Facebook, only to show you that you can actually mix and match a bunch of solutions. For example, right here I have maybe even you can take as an input a text query that was actually typed by your user. Put it in your system directly to extract the intent and give a visual answer to your user. Again, so many examples, and only so you can see that you actually don't have to do everything. So, as I said in the beginning, I think there are really, really interesting use cases for accessibility and so on, and every app should do it. But I really think there are very specific niches where this works really well, like creating stories for children. I think it can be really fun, even for adults. Building, why not, voice-enabled games. I worked in a personal project where we used the voice to basically answer things and do some quizzes and small stuff. It's so much fun. And the technology is working really well for us in order to build those kind of systems. So don't hesitate to build stuff on that area as well. Small models. I really believe that small models can tackle very, very interesting problems, such as for your industry. For example, you are, I don't know, in telecommunications or stuff like that, you have an app that is for your technician to do something, and he has his hand busy and he needs to do some kind of reporting, or I don't know, using voice, for example. And in order to do that, you don't need to provide like gigabytes and gigabytes of things that are going to be transcripting, making a transcription of everything he says, because there's only so much vocabulary that he's going to be using, because it's very, very specific use case for technicians that are going to be working on wires or so on, installations. So I really believe in order to do that, you need to build, of course, your specialized and your smaller model, but they are much more accessible for actually installing them much more easily on any device, Android device, or any kind of device actually. And I put another example here as well. This is something that I actually want to build. You know, when you start learning a new language and you have some sounds that are not present in your mother language, Again, maybe it's, for example, for us who speak Portuguese, we have some sounds in French that are not familiar to us. So there are so many sounds, in French, and maybe you only need 100 words that exemplify all of the sounds that are present in French. And for this, in order to be able to detect those words, you only need a really small model in order to do so. So maybe pronunciation apps for pronunciation exercises. I really believe that you can build something really interesting. Of course, as I said in the beginning, hands-free actions, cooking, or maybe you're too lazy to go get your phone and you just talk with it. You can take. And in those past months, even years, we can see so many people making so much efforts on building like new voice assistants with very new, fancy and cool and powerful GenAI models. But it would be really, really great to see a bigger bridge, a link between existing apps that are running on our devices and those systems, not only with API calls, but with the system as a whole, as I said before, with the app actions. My personal point of view is that offline is going to be key in this world, but in the meantime, let's keep building and experimenting. And with this, I thank you. Thank you very much.